All right, so hopefully I'll have better technology look than David just had, just to show that I don't trust technology. There is what you're getting recited if this doesn't work. So, right, so I'm Rob King. I'm a tech lead at Market Study Insurance. I've been there for about 4 or 5 years, and before that I was at Bede, which is where Peter is, and there's a few other ex-Bede folks in today. I'm here to talk about Minimal APIs and Blazor. I've refreshed it for .NET 8, since that came out last week. It's really for those who are new to Minimal APIs, or maybe have some experience but haven't used it in anger. I'm going to start with the fundamentals and then go into a design pattern that I like, that I picked up at a conference about a year and a half ago and I really like. And then in the second half I'll go on to Blazor, which mainly is really for people who are new to Blazor as well, or maybe used it a little bit but again haven't used it in anger. So actually, just because of the time as well, can I just see who's familiar with Minimal APIs at the moment? I just want to know how quick to go with that. So you know some stuff. Okay, cool. And what about Blazor? Okay, a fair few. And who knows what on earth LCARS is? Half the room. That's it. That's good. I expected better. But right, so I started this because I basically wanted to learn the technologies, and I had an old dashboard that I made many years ago. Apparently it's still on the screen to Bede if you turn them on. I was told the other day it's still there. I don't know if you've seen it around. But basically this is a complete rewrite of it with Minimal APIs. So first and foremost, what is LCARS for those of you who don't know? It's basically something that's been around since 1987. It's been the computer interface in Star Trek in 4 TV series and 4 movies. It's basically it's one of the most nightmarish user interfaces you could ever experience. It's mostly numbers and random shapes, and half the interface is wasted by white space. So I thought that would be ideal. Because it could even look like that. Okay, so what we're going to build is a dashboard that will give us the status of several of the key, some tools that people might be used to using, TeamCity, GitHub, etc., the ones you see on the screen. And what we'll do is we'll do this in 2 halves. I'll start with the Minimal APIs, talk about what they are, why they're different to controllers. I'll probably go through that pretty fast given the show of hands. The advantages and drawbacks, and then I'll go into that design pattern for the majority of the time. Then I'll move on to Blazor, talk about Blazor Server, Blazor WebAssembly, compare the two, and then also go into what .NET 8 brought us that solves most of the problems that Blazor has always had. And then at the end, I'll go through some of the code on the dashboard itself. So first, we're going to have a look at a comparison between a Minimal API and a traditional controller. This is the controller here. There, you know what everyone's used to seeing. This one here is just going to return a list of strings. Doesn't do anything more than that. But really, the point of a Minimal API is if you look at that controller there, that's quite a lot of code. You just look at the line count and see the amount of code for what it's actually achieving. And so we end up here with the root attribute, the API controller, the get, the controller base implementation, all these things that have to be repeated in every single controller that you create, and then repeated again if you're going to have puts, deletes, and patches and all those sorts of things. You need that attribute everywhere, and basically it's an awful lot of code. So the Minimal API has come along, and essentially that is the equivalent there. So this is a Minimal API application. That is the entire application. That's in program CS, so that is the exact same as you had before. But the key is that that previous slide is replaced by one line. So we now express in one line that you're going to be making a get endpoint, you give it a root, and then we have a lambda to say what you want it to do. And now you don't need any of that boilerplate, and you can end up with basically an extremely simple application. And you could run that right now, and that would be absolutely fine. That would run. It's quite good, actually, even just as simple as that, to use this sort of thing for a health check, maybe on a server or something like that. You know, it doesn't need to be any cleverer than that. You could just return an OK. So basically, just to show side by side, that is what we end up getting from a Minimal API in terms of just trying to make everything just brevity. That's the key word. Microsoft used that word more than anything in any. If you watched .NET conference last week, the word brevity was used more than any other word, and that is what they're focusing all their efforts on at the moment. So there we go. That's as far as a lot of the times when I've gone to a talk or to a conference, the guys kind of spend an hour getting to that point and then say, there you go, that's Minimal APIs, off you go. And that's what everybody walks out of the room thinking. So basically, nobody wants to put their whole application into program CS. Nobody wants one file that represents all of their business logic. So what we're going to do now is just flesh this out and see how you can end up in a mess and then how to solve that mess. So I'm going to get away from the dashboard for a minute and just do this in the abstract and do person, because everybody likes doing person in a demo. We've got a more fleshed out minimal API here. The top 2 lines are basically just setting up the application itself, but then what we get is this first line here. We've got a get with a person, and it returns an OK, but we want to return a person with a specific ID, and what's happening here is you can pass in parameters, and as long as the parameter on the method matches the name that's on the URL, it will automatically match them up, and it will automatically mean that you can call that URL and it'll get fed into the method that it's going to execute. And then it'll return you an OK with that person. But also, if, for example, with this post, there's nothing matching person on that parameter. So it's also smart enough to know that it's going to get it from the body, especially with that being a post. It knows that there's going to be a payload, it's going to represent a person object, and then it's going to take it and return a created with that person. Sorry, jumped ahead there. So this basically here, right here, oh yeah, and another key thing is there's no from body on there. Another difference with the controller, you do not have a from body on the person. It's clever enough to know without having that. And this is all nice and tidy still, but it's not really doing anything. So we're going to add some functionality to this rather than just arbitrarily returning an OK, which isn't the best of APIs. So what we have here, we're going to add a repository. And the way you can do that is you can actually inject your repository directly into the method that's going to execute on the endpoint. And then you can use it inside. You can also then use await and async and await as normal. And then if you notice at the top, we register the repository here, which is what just sets up the dependency injection. Is it just like you would in any other application? The line is basically identical to when you're using controllers, but now you can see it just above. So now that's a fully operational, apart from the repository code, which would be in another class, that's essentially a fully operational CRUD API, away and ready to go. But then have a look at what happens when we start adding a few more concerns to our API. So this is now doing quite a bit, but the problem is we now have a massive program CS file. It has everything thrown into it. We've broken the single responsibility principle completely. We need comments just to group what on earth's going on. It's going to quickly become a nightmare. And also, at the moment, all these are doing is single line tasks. This couldn't actually be any simpler if you wanted those 12 endpoints. As soon as you start adding any validation to the posts and the puts, and you start actually putting a little bit of business logic in there that does more than write to a database, it's going to get awful, as you can imagine. So, to talk about minimal APIs and the pros and cons of them before we move on to try and solve this, they're great if they're used correctly. They have a lower barrier to entry, insofar as it's really simple to get one up and running. There's a lot less code, there's a lot less messing about, a lot less files, they're easy to read, but also they have their code in one place. The other thing is the code's basically in one place, so there's no like map routes going on in program CS that says this is how my routing will work, and then over here I've got my code that's executing on those endpoints. It's all just together, so the map get is saying map get, it's going to be here, and this is what you're going to do. So again, you can just look at the one file without having to hunt around your solution for what's happening where. Also, they are statistically proven to be faster under the hood in the uncompiled code as well. So if performance is what you're after, then a minimal API is the way to go. And then the big drawback is basically what I just showed a minute ago, which is that it'll become a bit awful if you don't structure it and you're not careful. So that's what we're going to talk about now. So for the dashboard API, we're going to start with the GitHub endpoint. And basically the dashboard's going to show how many pull requests we've got open in our team. It may be a list of them with how many comments they've got, and who opened it, things like that. And then another one maybe that has, I don't know if you suffer from this, but we often get a lot of dead branches, so you maybe have something on the dashboard that says these repositories have this many branches floating around, so you can keep an eye and make sure things are kept tidy. So that's what this is that I'm going to go through. So the first thing we're going to need is an endpoint, and we want to get everything out of program CS. So create a class called GitHub endpoints, implementing that interface. I will come back to the interface later on. And then we've got define endpoints, which is the place we're going to move our mappings to. So we'll populate that. And this is the same, except now I've moved my two map gets into here from program CS. They don't do anything yet. But this gives us our base, and this is now established. Those endpoints will work. I mean, they won't do anything, but they're there. So the first thing we're going to do now to actually flesh this out and implement it is we're actually going to replace that comment from the previous slide with a method, and then we'll define these methods below. And there are two ways you could actually implement these methods as well, two different approaches. The first one is represented by this line here. So what we have here is you're telling, when you're reading it, you're actually saying, I'm going to return a list of pull request objects. You don't have iAction result like you did in controllers. It's not as abstract. It actually is telling you it's going to be a list of those. You call a get, you inject your service, and then all it's going to do is call get pull requests. And that's really straightforward because all it's going to do is say, go get me a list. It's always a 200, even if the list's empty. So that's nice and easy to read, nice and clean. But sometimes that's not good enough because, for example, with this next one, with get branch, you're doing the same similar thing. The difference is the branch might not exist. So what you do is instead you can use a new thing called iResult, and that means you can return what's called, it's basically like almost like an enumeration. But essentially what we're going to do is grab the branch using the name that was passed in. If there isn't a branch that's called that, it'll return a not found. Otherwise it'll return an OK. And by returning that task iResult, that just gives you that flexibility. But if you've got something as simple as the first one, you can make it more readable by just going straight to the type that you're going to return. And I'll usually go back and forth depending on ease of reading. I'll use the top one if I can, and if not, switch to the second one. Yeah. So we have our endpoints class, and it's calling a service, and in turn, that service is going to call GitHub and its API and do something. By the time it's all complete, we end up with this sort of structure. So we've got our models that are used within the API. They represent what's coming back from GitHub. Then we've got responses, which is actually what we're going to return to the user. And then the reason we have them separate is that we don't really want to expose business objects to our consumer, so the responses are sort of shaped to suit the dashboard. It will only expose the stuff we actually want to return, whereas branch, comment and pull request, they might have more in that are needed for the GitHub side of it, but for returns we just want to keep that clean. Then we've got the GitHub endpoints that I just made, and I'm going to flesh out in a minute. And then the service, and I'm not going to go into that now, but essentially that's just the thing that talks to the to the GitHub API. We don't need to go into that. So then you do TeamCity and you do Jira and you do Bitbucket and you do all the other things you want to integrate with, and you replicate and you keep that folder structure that I just showed, and suddenly you end up with this. And now that suddenly, I mean, imagine if that was all in Program CS, but basically it's a step away from all being in Program CS, but it's not ideal really, is it? The first thing that people would normally do here is say, okay, well, nobody wants to leave it like that, so we'll make it a bit better, and so it's hard to see in the back. But basically, let's improve the grouping. Let's have endpoints all together, the models all together, the responses all together, and the services all together. And this is better because we can help find it if we know what layer it's in, and that's all well and good. But what we've ended up is the separation like this. So you've got, I really should go to the slide first, but essentially you've got all your endpoints, it's grouped like that, and that's pretty much an MVC pattern. We're all used to seeing that. The problem here is it's not always ideal, because if you decide you want to go and look for something that your TeamCity API has got a fault and you need to find it, and where are you looking? You've got 5 directories there that have TeamCity concerns in them. And yeah, okay, it makes sense that services live together maybe, but not always. And what you could do instead is think about grouping them by the concern itself and keep them in a directory together so that they're almost like a module within your application. So grouping by domain essentially. And then what you end up looking like is that essentially. And now this feels a lot cleaner to me. And now it also means that if we ever stop using Bitbucket, for example, just moved away from it, you can delete that directory and that part of your API is gone. You essentially build microservices within one app, but this app doesn't warrant, I'm not going to break this up into 5 microservices, that'd be crazy. So you're kind of almost using the pattern, but within one app. But it does mean you still have the ability to delete, say, Bitbucket, and you won't have to worry about breaking any of your other endpoints. It also means that if you wanted to come in and add Azure DevOps API or something like that, you would just create a new folder, add all your new functionality, and you don't have to regression test anything because you haven't gone anywhere near the existing functionality, and you've just reduced how much scope you need to test on your new work. So I forgot something on that when I was talking about it. I've just said that everything's going to be in individual folders, but what we haven't sorted out is the dependency injection. So if I was to do what I just said and go and delete Bitbucket, this line here where it's registering the service would suddenly not build anymore because you've just gone and deleted a big pile of code. So if we really want to encapsulate all the domain logic in these folders, we also really want to move that in there as well so that it truly is encapsulated. So, and this is where the endpoints interface that I mentioned comes into play. We already did define endpoints, so that's taken care of. But also we're going to do a second method called add services, and that's what we're going to focus on for a second. So add services, I'm going to add it in. There's a define endpoints is what we did before, and we've got our stuff in there. And now we're going to create this add services. We're going to move the services.add scope for GitHub into this method here. So now this class, this single class, is responsible for having all your endpoints, all the things it calls, and then also defining all of its own dependencies and wiring them up. I mean, this basically also means that it's right in front of you, so you won't forget, because you need to wire up every dependency of this endpoint. And you won't forget that it's over in some other file because it's right there in front of you. I know I've forgotten it more than once. So that's all well and good. We've created the add services and the define endpoints, but we haven't actually called those methods anywhere. So they're just sitting there uncalled, so that's no good. We need to solve that. And then, yeah, so the way we're going to do it is we're going to do a search, basically, through the app to find anything that implements endpoints and then register it. I'm going to do that now. So we'll start with add services. So we've got an endpoints extension class, static class, and we're going to go through what it's doing. Signature gives away that it's an extension method. It's extending iService collection, which is what the app builder uses during startup. And then it uses that to add services to the application. The next thing we're doing is we're going into the app and we're saying, give me every type where it's not abstract and not an interface and implements endpoints. And the reason we've got this filter in there is that if you were to try and, you basically want concrete things that implement the interface. You don't want anything that, another interface that implements an interface, because if you try and execute code on it, it's going to fall over. Also, abstract classes are the same. Now, this dashboard doesn't have any of them, so you could actually leave that entire abstract and interface bit out, but you would want to do it in a real app. And once you've got them all, you can iterate around them and then invoke it to basically add it to the service collection. And this means when you come along and add your Azure DevOps one, you don't have to touch this. This is done now. This is written, so you can forget about it. You can just create the new class, put all of your endpoint work in, put your mappings in, and it'll find it without you having to do any more work. The use endpoints is the same approach. The first bit's actually identical, and then this time the difference is you're saying you want to define the endpoints. You want to call that for each of the classes that you found. The difference with the two things is that one is adding services, so it's done when you're building the app, and this one is done once you've built the app and you're now essentially where you do add and then you do use. This one goes in the use. It's like when you put use endpoints in with the built-in .NET class, which is here. And the only other bit I did was I took that bit that was in both places and just basically abstracted that out into a method. But that's essentially what you end up with. That's your finished endpoint extensions class. And once you've got that, you'll never touch it again. You forget about it. And this whole thing that I'm talking about, this entire repo is on GitHub, open source, if you want to have a look at it. But yeah, you'll never write that again. And then finally, we just do what I said before, which is you stick your add endpoints into your startup and your use endpoints after you've built the app. So for this design pattern itself, and by the way, do just everyone say slow down if I'm going too fast because I'm just aware of the time. Full credit to Nick Chapsis, who did a talk in this NDC last year It was last like the year on January. He's got a video on YouTube that is about an hour just on this particular thing. He goes into more detail of how it works under the hood and a lot more of the intricacies, but ultimately the implementation pattern is the same. And then, as David was showing before, obviously you can bring up your Swagger, and you end up, once you've got your API built up, it'll just run and look just like controllers. There's no difference. Because actually, Dave was going to save me some time here, because I was going to go in and show this bit, bringing back some data, but just trust me, it works. Right, so moving on to the UI in Blazor. We have it, so if we've got, basically what we've done there is we've built the API, and obviously then we'll roll it out across all the different areas. So you've got endpoints that will return everything you need from the various services, and now we just need a way to display them to the user. I'm going to use Blazor for that. So for the next bit, I'm just going to talk about what Blazor is. Again, you've all indicated, most of you know what Blazor is in general, but I'll go over it and what Blazor Server is. I'll also cover static server rendering, which was just released last week, apart from in the previews, WebAssembly, and what else has changed in .NET 8. And then after that, I'm going to run through the dashboard. Okay, so ChatGPT, I asked it what is Blazor, and that was the answer. So it wrote the slide for me, which is great. I won't read it out to you, but basically the critical piece that everybody cares about is that. It basically means you can write a full stack web application and never write a line of JavaScript. I'm sure there's people in the room who like, I know there's people in the room who like JavaScript, but actually, realistically, you shouldn't. So, let's be honest. This means there is actually not a single line of JavaScript in everything you're going to see from this point onwards. I can't tell the lie there's no JavaScript in the app, and that is because when you create a new project, there is a line at the bottom of your HTML template that says, bring this, it's called blazor.js. It basically brings that in. So that's a Microsoft's part of the framework. We don't need to worry about it. But there is JavaScript involved, unfortunately. But yeah, there you go. So, Blazor Server. So we'll start with that. There's two flavors, Blazor Server, Blazor WebAssembly. I'll start with this one. With Blazor Server, the server is sending HTML to the browser. But when a user interacts with it, with anything, it sends the request back to the server to do something else. So that's why you don't need the JavaScript. It goes back and it says, I want you to do this. The thing it's sending it to is all C#. The UI is then sent back some HTML for rendering. The browser doesn't do any work at all. It just receives DOM updates, and then it renders them. So to be clear on that, every button click, every user interaction, every form submission, it's all being sent back to the server, like absolutely everything is. And this isn't like the old days of ASP web forms, where you're actually posting a page back and waiting for a page, and you get the big refresh and all that, and it's really slow and terrible. This is actually using SignalR, and it's sending its requests over a permanent connection that it always has to the server with what it wants to happen, and then it gets back a response. It'll only re-render the bits that have changed as well, a bit like React, in that it's smart enough to know what it needs to do. And it's clever enough that if it loses a connection, it'll go and get it back. So if you go through a tunnel on a train or something like that, you're not going to suddenly lose all your work. It'll pick up when it gets signal back. But while you're in that tunnel, you can't do anything. I mean, that is the trade-off. You do need a network connection or nothing's going to work. So when you create a project, and it's like now in .NET 8, you basically on the creation screen, the important bit is the button, this drop-down. And I've got server selected there, and obviously I'm going to just quickly show you a Blazor Server app, and that's what you would pick. You get the choice of server, WebAssembly, and auto, and I'll come to auto later on. So when it creates it, this is what you get. As of .NET 8, it now all belongs in a components directory. That's the root of everything, and you've got layout and pages. Your common components, or maybe some small things that aren't pages in their own right, would be in the root, or maybe a directory you make for yourself. Pages obviously pages gives it away, and then layout contains the main template, and in this case the menu, and anything else that you want to be part. You might have multiple layouts for different areas of the site, so you put them all in there. Then wroot has your static assets in, like favicon, images, CSS, and that is the entirety of the application when you create it. So let's hope this works. Okay, so this is Blazor's server on the left here, and this is it on, this is the code. So I'm going to start, now I'm not mirroring here, so I'm going to be leaning a bit. So let's have a quick look. The important really wants to show you will be, you've got hello world, that's nice and straightforward. We've got this counter page here, and you just click that, you know, that's the most basic in the world. So to go through what this is doing, you've got this here, a render mode. I'm going to come back to that in the next bit. So we'll ignore that, pretend it's not there. And then you've got the page title, which is a component that just lets you set the title of the page. That's a built-in thing for Blazor. And then what we've got here is it comes down here, and you've got this variable current count. That's set to 0, and then we've got an increment method. And with here, it's actually just saying render that little screen, and then when you click this button, I want you to call the increment. And what happens is you click that button, it'll post back to the server. The server will come back with, it'll update current count, and then the app knows it needs to go into all this code here and find out what effect that'll have on the DOM, and it'll work that out and send the new markup back, and the markup changes that need to happen back to the front end. Because of all like messing about with, if I open up the Chrome tools, it's going to be tiny, but basically what you would see is just like in React, you'd see just that number 6 flash in the markup and become a 7. It's not an entire page refresh. And then we've got this weather bit here. Now, with the weather, let me just get that open. This has something at the top that's slightly different, and this is .NET 8 as well. This is called stream rendering, and what that means is that the page will not wait for asynchronous things to finish on the page load before it tries to render you something. So what will happen is it'll come in here, and at the bottom, so you've got this code block. This is all built in, right? This is all what you get when you create a new project. This is like a dummy API. It's waiting half a second and just giving you some data, but it's as if you were calling an API. But what's happening is it's coming into here, and that might take some time before this forecasts object is modified. And what stream rendering will do is say, don't wait for that, start at the top and try and render this. And it'll do the header, it'll do that bit of text, and then it'll say forecast is null, say loading. And I click here, see how it says loading for just half a second? Because it hasn't got the data yet. So it's giving you some way, you might have a swirly on, you can do whatever you want. You can have anything in here. Yeah, literally anything. But then once this is finished, it knows to then trigger a re-render of the markup above. So that'll start at the top, it'll go down here, it'll say, I need to know what the change in forecasts is going to do to this page. And straight away it'll say, well, that needs to go away then. And then it'll render this, and it'll loop forecasts and write the data out. This is random data every time, so you keep clicking it, but that'll happen every time. And that's what this gives you, this stream rendering here. The only other thing to mention on this is we've got this page attribute. That is giving you the URL of the page. If you don't have a page attribute, then it simply isn't a page. That means that the URL is weather, which it is if I just go up there. And then you've got counter has counter, and home just has a /. So that is how all routing is done. You don't need to do any attributes or any messing about or anything in your program CS. That just works out of the box. What you can also do is you could, on the next line, do @page/home, and now both of those URLs will render the page. And you can do that as many times as you want. There's entire things on Microsoft Learn about this, because you can do things like you can put parameters in it. So, for example, like counter on the counter page, you could have /counter, and then in squiggly brackets the word counter, and then that variable that we declared that further down would then be the URL. So if you went to that URL, that would be the initial value of that variable. So that's how you can pass data straight into a page. Okay, so I'm going to move on to static server rendering, which is new. So we know what Blazor server is, but this is the new flavour of it. Solved quite a lot of our problems actually. This is a way of just getting HTML to your user. That's all you care about on a page that is set to be like this. Users can't interact with any of the content. Buttons won't work. You can't submit forms. Basically, it is just, here's some HTML, there you go. And the page will not open a SignalR connection either. It won't even try. It will just take HTML and put it on the screen. Your links will work, hyperlinks, but that's pretty much all you're going to get. And the important thing as well is that this is the default. This is what a page is if you don't tell it otherwise when you add a page to a project. So to go back to this, and this, I'll try something that, try an actual demo bit. Go into counter here. This is what tells it that it's a Blazor server page, and if I do that, it's now a static server rendered page. That is now no longer going to open a single R connection, and that button is not going to work. And I won't do it. I'll just take the word. If I build this now and then refresh that counter, basically nothing will happen. This is great. The static server pages and the home page, just as to show as well. Basically, that's the idea of it. Is really the home page out the box is like that, because that's what you want. You want Google to arrive there instantaneously, fast as possible. SEO. Users aren't frustrated by not getting what they want. When I come on to WebAssembly, I explain, because that's been the biggest problem with Blazor, is that you couldn't do that, especially with WebAssembly, and I'll mention that again in a sec. So, moving on to WebAssembly. Blazor WebAssembly, the last flavor we'll go through, it runs, this is completely different, it runs entirely in the browser. There's no server element at all, there's no signal R. You don't need a permanent connection to the server at all. When you load a Blazor WebAssembly application, it downloads the entire app to your machine, and then essentially as an assembly, it just runs in the browser. The concept is the same. The UI is controlled purely by the C#. The syntax is the same. Everything I just demonstrated with Blazor Server is the same. So you don't have to learn different ways of programming, but it runs, like I say, all locally. Flash and Silverlight have done this before, we all love that, and offloading processing to browsers isn't anything new. The difference here is it's out of the box. Basically, if you have a version of any modern browser, it'll just work. You don't need a plugin, you don't need anything. It's no use to you if you're in an enterprise who insist on IE8, but you've got bigger problems. So yeah, basically, when first released, Blazor WebAssembly was actually quite large, and it was a big problem is that you land on the site and you get a little progress bar, and it says I'm downloading it. I think it was around 12 meg when it first came out. We've actually managed to get that down to 1.1 in .NET 7, and I believe it's marginally gone up, but it's still low in .NET 8. But we have solved it. They have solved it. They've solved it in .NET 8, which I'll come to in a second. But even to be honest, with 1 meg, it's terrible for your homepage. But the way I got around this in .NET 7 was I would have a static website over here, a different project, that had 3-4 HTML pages, and once you'd logged in, you'd get redirected back to your WASM site, because people don't really care about waiting 3 or 4 seconds after a login. But now you don't need to do any of that. You can just set your home page as being static, and you can set your WASM page as being the bits further in once you've got them used. But it gets even better than that, which I'll come to without spoiling it. So, comparing the two. Blazor Server is great because it's a small payload and it's fast initial load time. It also means because it runs on the server, it can do things like you could have a Windows authentication connection to your SQL database, or you might want it to talk to things on your network that need to be really kept private, and you wouldn't want to download something to the client that's talking over the internet, because you have to expose things on your network and you might not want to do that. And also you can use it on IE8, you can use it on anything that will render HTML. But with WebAssembly, you can run it offline when it's downloaded, which was pretty awesome really. It's just like having an app on your machine. But also you can host it on static sites. You can put Azure static sites, you could put it on Google Firebase, you could actually just run it from your C drive. It doesn't need a host, so it's obviously cheap. And the other thing is you're offloading processing to the clients. I'm going to show you this on the dashboard in a minute. You're actually not making your server do all that work. If you have 10,000 Blazor server apps talking to your server, depending on what they're doing, it's going to get a bit of load on there. If you've got 10,000 WebAssembly apps doing their own thing, your server's not really doing anything. So there's a huge benefit in that regard for scalability. Okay, so do we have to pick one or the other? The answer has always been yes. You pick the type of Blazor app you're building when you create your app, and once you've chosen, that's it, you're wedded to it. Whereas with .NET 8, that's not the case anymore. You can now choose, as I showed in that previous slide, you can choose server, you can choose WebAssembly, or you can choose automatic. And this is probably the biggest thing that .NET 8 brings. It's the biggest enhancement to Blazor by far. And what happens now is that when a component is first rendered, if it's marked as being Blazor WebAssembly, it will actually behave as a Blazor server component, and it'll give you all of the benefits of Blazor server, and it'll be instantaneously available, it'll work. And then in the background, it's going to download the WebAssembly, and the next time you need it, next time you come back to that page, it'll use the WebAssembly. So you've eliminated completely that delay and that horrible loader and everything. You get the best of both worlds, basically. You start off with server and then kind of upgrade almost to it. It's not always the answer Blazor WebAssembly, but most of the time you probably want to go down that route, to be honest, now that we don't have this huge drawback. So just to quickly, this only takes a second, this one, because there's not much of a difference in the two things to look at. So in here, this one's with the automatic. Just want to show the difference in the project here. This is all identical. You'll see it's the same. But now, if you create an auto one, you'll get this client project down here as well. And what that is anything in here will run as WebAssembly after that first load, and everything back up in the main app will just run a server. You're not even bothered about WebAssembly for them. So in the Hello World app, what they've done is they've moved counter, because the counter has nothing in it that needs a server. So that's ideal. And what you get is at the top, the render mode isn't interactive server, it's interactive auto. There is an interactive WebAssembly, but that's more, I believe, for backward compatibility. I'm struggling to think of a reason why you would want to not have auto. I've been trying to work out a reason in preparation for this, and I can't think of one. So basically, you want that on the top, really. And it will work exactly the same. I'm not going to go through that, but it's just to show the difference in the project structure. And if I wanted to move this home page to be a WebAssembly one, I would literally just cut and paste it down here, and then add that attribute, and it's now a WebAssembly component. Simple as that. That is that, and then I think, yeah, now the actual dashboard. So going back to, let me just get that code. One sec. Am I in the right one? Yeah. Nope. Right, let's try this out. Come on. There we go. Right. LCARS dashboard time. So this is obviously it's not the most useful thing. So this page here, which is what I'm going to focus on, is Team City builds. So like, for example, you've got this header component here. This is just all in the frame. We're going to talk about digits in a minute because that's really important for showing why WebAssembly is better for some things. But this is just literally a grid that goes off to Team City, gets a load of builds. It's going to refresh every 5 seconds for the demo purposes. The idea is you'd see this number sort of increment rather than it just being random. But yeah, that's all your Team City builds, basically. And I'm going to just show the code of how that works. So if I just bring this over, this is going to be weird with being on a big screen. Yeah. So, builds. Right, so this is the page. We've got the header. And I'm going to start with the header actually, because showing really how components can be. Actually, I'll come back in a second to build, but that's this header here. And then this is the thing with stream rendering. And then we've got the main thing, which is just we're going to loop through the builds, and it just writes them out in a big, long flex thing. And then my initialize calls refresh, which goes off to an API and gets the latest data. And because when the user clicks a button and does something, and then a variable changes, it'll just refresh the screen and it'll sort itself out. But because this is on a timer and the user's not doing anything, you do need to tell it that something's happened. And this is a built-in method for doing that. And I've created this timer here, and there's a little bit of logic on whether you want it to say success or the build number, or there's a little bit of logic just to make it look right. But the important thing here is it comes in, it does the loading element, which was that Starfleet symbol, the Federation symbol that appeared when I first loaded it. And then it does that stream rendering to render this up. And that's that. But this header bit is going to show a little bit of what power of the component modulars. If you've done much React, this is all be very, very similar. So header here, let's just see if this is the, yeah. This component, this is the header component. It's a div, it's got a left title, spacer and right, left, title, spacer and right. If anyone's a front-end engineer in here and thinking, why on earth are you programming like this, Rob? Then I'm not a front-end developer, so sorry. I know a couple of you who are thinking it. But basically, you've got, in the code here, you've got this parameter text. And that's the important bit, because it means that you've got a parameter here that's available to you for whenever you want to render that on the screen. You can call it built. So this header is reused throughout the entire application, but you can just pass in the different heading for it. And then we've got what's called styled components. Now I've got to find this one, I can barely see. So you see the file here, header.razor. Underneath it is header.razor.css. So what you've got here is the styles for this component, but they are scoped all within the component itself. So it means you can give them nice names. You don't need to worry about lots of underscores for making sure you don't get collisions with other components. You can call these anything you want, and they'll be given some random GUIDs and random stuff going on when you're on the output. So this is what I want my header to look like, and then in the markup I can just have something that looks a little bit nice and clean rather than having got awful classes on it. And you can be as generic as you want. You can treat it like that's the only page in your app, because it'll never collide. So that's what you get with the with that. What was the other thing I was going to quickly have a look? 5 minutes. Yeah, 5 minutes, yeah. Depending on how many questions I get. So, 15. Yeah, so I'm not going to go into every page, and in the interest of time, like I said, this is all on GitHub if you want to have a look around anyway. But just to go over a couple of little key pieces, the digits one I want to talk about first, and that is, if I just go back to my code, go to digits. Again, this is just something where you've got this thing called a markup string where you can build some HTML if you want. You can do this loads of different ways. I just threw this together to get it on. It's only a digits thing. But this is a perfect example of something where you would want to have it in a WebAssembly component. And that is because that, every 2 seconds, is going to run something, and it's going to say, right, re-render this markup. In Blazor server, that would actually go back to the server, say, can you build me some markup? The server would run this little bit of code here and send it back. And yeah, that's not much. But if you've got a lot of clients calling your server for that every 2 seconds, it's not ideal. But if you put that into WebAssembly, just by changing the render mode, that's now completely running in the memory of the browser, and it'll never bother your server again. So it was a good example for that. I've actually got an even better example, but first what I'll do is I'll just go into this config area. This is where you can configure this dashboard. You can go down each one, giving it things like the access tokens and all that. And I've got a thing where it'll turn it all into yellow alert. If you've got a branch or too many branches, it'll skin it to be yellow alert and bits and bobs like that. But this is using forms, one of the last two. Don't worry, because it hasn't got much more to do. Don't do that. So I've gone admin, go into, for example, deployments there. Yeah, so basically you've got here, you've got a form, I've got some settings. Some of my settings are like enabled and key. I can attach that in my model, and then I can do an input checkbox and bind the value. And this is two-way. I've got a save button, which is again just like the header. It's just a custom little button that I can style however I want. You can then have execute this code on a valid submit, or this one on an invalid submit, and then basically on my model I've got required. It's just like normal model binding that you've seen a million times. But the idea is if this is invalid, it'll come down and it'll execute that code, set a variable, and what that does is just affects the header up the top, puts a red header on the top. So they've given us a load of these built-in controls. When I first saw it, I started to think, God, it's ASP when forms are back. But actually, it's really nice to use, really simple to use. And I'm going to use it now to do the last bit, which is my favourite bit of the app, and I'm just seeing it knows this. But basically, I'm going to enable red alert. What time are we on? No, we're okay for that. So that's already set to date. So it's beer alert. We go to the pub after this. I'll save. And there we go. So there we go, my favourite bit of the whole app. This is my other example of where Signal would not be ideal, and this actually happened. I made this back in .NET 7, and it was a Blazor server app. I eventually converted the whole thing to WASM, but what was happening was I ran it locally and it was all great, and I was done. And then I put it on a server, and I put it on some screens in the office, and every millisecond this went to the server, and then 8 screens were running. and basically, yeah, it lagged a bit. So basically, turned that into a WASM thing, and now you can see that's running. And it would anyway, it's local, but you know, basically, it's a perfect example of you don't want someone battering your server every millisecond just to put a red alert on, which we're quite happy about. But yeah, basically, go. So that is it, and I'll just leave that clock on, I think, because there's nothing else to do except, I think, Q&A. There you go, for those of you who've seen Star Trek. Does anybody have any questions?
I guess.
Yeah.
Yeah, you said you would not use WASM, not server edition. Where would you use? Would server be good for the screens when I push an update that's might be every 5 minutes, for example?
Yeah.
And we want to push it not forward, if you get what I mean.
So a good example actually is that build screen that I've had on there. That is talking. See, for a dashboard, it's irrelevant because my dashboard's on my network anyway. But as an example, if I've got that running as WASM, the actual build thing, it wants to talk to my API to get some build Team City data out. If I put that on WASM and go and put that on the internet, I've now got to have a outside world-facing API endpoint for it to get that data from. So you're going to want that to be Blazor server so that you keep that all on your server. And because it only updates that screen every 5 seconds, then it doesn't matter. That's absolutely fine. In fact, if it couldn't handle that, then Blazor wouldn't work. So that's when you want to be on server. The digits and the red alert and all that, because they're all about just render, and they're not sensitive, then they're perfect. The header actually, even that header with the builds that I showed, that's rendered as a client thing. It's like, don't come back to the server for that.
Yeah, you need to set an API with authentication, HTTP client, everything,
yeah. And one thing I didn't actually show here was just quickly just show on. Yeah, it was on counter. Was it counter? No, I'm gonna. Not gonna find now. Basically, what you can do is I only showed it there where at the top you said render mode is interactive auto. You can actually decide when you declare. So when you put that digits component onto a page, you can actually in a parameter say render mode is going to be WASM or auto, and then you could put that same digits thing on another page and say render mode is server this time.
Yeah, so if you want the components there, you could set what mode you wanted it.
Yeah, I forgot to talk about it, but it is done on one of the demos.
I saw it. Yeah.
But you can't do that and put it at the top of the page though. If you do that, it'll fall over and it'll say, hang on a minute, you've told me to be WASM, and now, but at the top of the page you said you were server.
I mean, declaration's different, yeah.
Yeah. So you have your hand up there.
Yeah. Just really advice on the, or asking for some advice, I'm not giving on the API front. Like, I see a lot of very detailed examples of how you use every specific HTTP verb and do CRUD operations and stuff. But if I want to do something unusual, like in the Git example, say I want to rebase a branch or merge a pull request, like presumably is just like would you just normally just use like an HTTP post and say, okay, I'll do like pull request /42/merge and post that. Like, would that be how I would do a merge of a pull request?
Yeah, I'd say so. Out of all of the verbs, I think in that scenario, yeah. I think it all depends on for that example, I would use post. Yeah, absolutely. But I do tend to use patch if I am just updating an object. If I'm just saying, so for example, if I want to send the value of that counter back to a server somewhere, I would patch that. Yeah, basically that would be where I draw the line. But for what you just described, I'll post it. Yeah. Cool. Right. I think we're getting thrown out, but if anyone wants to chat with us, you can. Right, in case.